In this section, we are going to create a form of intelligent AI for our security guards. Our guards will be given unique paths they will follow, utilizing a finite state machine, which will control the animation state between idle, walking, and detected. We'll add eyes to our AI so they can detect Darren and trigger our game over cutscene. AI in video games is one of the most important elements to any great game. Our goal when developing games is to immerse the player. Nothing does this more than with a form of intelligent AI. In this video, we're going to take a look at creating an AI system that's going to be modular using one script that all three guards can work on and have their own individual waypoints on what they're going to be patrolling. So if we look at our guards here, they're positioned this way for a reason. We have this guard here, which is guard 1. So we're going to have this guy. He's going to be going from all the way to the left here, and then he's going to be going up. So he's going to be going in kind of like an L shape. Okay? And that's his route. This is going to be his route using the same guard script that everyone else has. This guard is going to just be idle because we want to sneak past him. So we're going to create a distraction system later in the course to get by him. This guard is going to be walking in an L position this way. So what he's going to do is he's going to be able to walk up here and he's going to randomly choose which way he wants to go. He can go either left or he can go right. He's going to have full control over that action. All right, so it's up to us to give him the ability to make decisions. So let's look at what we need to do to get started. The first thing we want to do is let's focus on one guard at a time, not all three. All right, but just keep in mind that we want to keep this as modular as possible. We don't want to have a specific script for this guard and another script for that guard. We want them to share one common script and have a generic code base that can be extended if we choose to. So the first thing we want to do is let's go into our game folder. Let's open up our scripts here. And let's create a new C# script called guard AI. Guard AI. Open this script up. You can reload the solution if it asks you to. Let's go ahead and organize our structure here. And let's get to work on what needs to happen here. So the guards are going to be moving between waypoints. Now, just like the player, it's on a nav mesh. They have nav mesh agents, and we want to make sure that they do have nav mesh agents. So let's set that up first, because they're very similar to our player, except for the fact that they have no user input. So in order for them to move along the nav mesh system, we need to add nav mesh agent components. So let's select every guard. Let's add component, nav mesh agent. All right, and it looks like it mapped pretty well to them, and it looks like it's going to be okay. All right, so from there, now what we can do is we can add component again, and let's add the guard AI script that we created. So now they can actually recognize the nav mesh. What we need to do now is have them move to destinations. But before we can tell them to go to a destination, we need to know about what are their destinations. So one of the things that we can do here is we can create in our script a list of waypoints that we want to go to and from. So if we open up our look at script, or I'm sorry, if we open up our guard AI script, we can create a list that we want to, a list of potential waypoints. So when you're creating a list, in order to create a list, you need to use a new namespace called using system.collections.generic. Unity as of 2017.1 provides this namespace for you. This library is going to give us access to using a list. A list is very similar to an array. However, a list is dynamic. That means that in real time, at runtime, you can shrink the list or you can extend the list. So you can add items to it at runtime while the game is running. You can also remove items from it at runtime. You can change the size of the list. With an array, it's a fixed length of elements. So if you remember from course 1 when we were creating the health system, we had a 4-element array and we couldn't add or extend or decrease the length of that array. Okay, so with a list, we can. And a great example of using a list would be like an item database in some RPG. You have 5,000 items, maybe you're going to have 51,000 items someday, right? You'll use a list to extend that item database because it's a dynamic list and you can just keep it going and extending. Another thing you could use a list for is collecting an unknown amount of items in a game. So for instance, say you had objectives to go around picking up objects and you want to add every time you pick up something to a list, you would do it that way. And at the end, you can get the length of the list, you can remove items from the list, you can do whatever you want with the list. All right, so what we're going to do is we're going to create a waypoint system here. So we're going to have a public list of waypoints. And this list here is going to be transform type. We're going to create a list of transforms. So here we have public list transform, and then we're going to call it waypoints. If we save this and go into the inspector, you'll see here that our player or our guards now have a list attached to their script called waypoints. And if we drop that down, you'll see here the size is 0. What we can do here is for this guard specifically that I have selected, I can set this to about, let's say I can set this to 2. We have 2 waypoint options. Now, this script is on all of the guards, but it's unique to this guard for this instance. So there's 3 instances of this script in play. It's on this guard and the other 2 guards. If I click on one of the other guards, they can have their own waypoint list, and the size is 0. So this guard's going to have 2. This guard is going to have 1 waypoint, or 0 because it's just going to be standing there, right? And then this guard is going to have how many waypoints? 3, because it's going to have its starting point. It's going to have its starting point here. It's going to be able to go here, and then it's going to be able to go to here, and it's going to choose a direction. Okay, so it's going to go from, here's our starting point, here's our first point, which is this L, and then our second point, which is this side. All right, so he can choose which way he's going to go. So we're going to have 3 waypoints for this guard. So now that we have our waypoints, what we need to do now is we need to actually assign these waypoints. It's looking for a position object. The best way I can recommend to do this is to take this security guard, right? He's looking for his waypoints of start position and end position, right? Point A to point B. The best way to do this is if we duplicate this guard, let's put him in the start position. So his start position is going to be here, and he's going to be walking along to all the way to the L-shaped corner over there. So what we want to do is let's select him. Let's duplicate him by holding down Control D to duplicate. You can also right click and duplicate. And what we want to do is let's drag him over here. Okay? And let's push him to his end goal. So push him so he has a start destination and a target destination, which is over here. Okay? So from there, what we can do is we can then rename this object to guard. Let's call this point A. Okay, so underscore point A. From there, what we can do, guys, is we can say point B. So let's go ahead and create this guard again. Let's duplicate it, and let's call this point B. Point B. So for this security guard, we have 2 waypoints. We're going to go from point A, which is all the way over here in the corner, to point B. Okay? So make sure you select the security guard and point B. There we go. Now, in order for us, and we're going to clean this up in terms of organization, but what we want to do is we want to focus on getting this functionality. So we've created some waypoints here. And what I want to do now is we need to hide the objects here. We don't want these to act as AI. So let's select both point A and B, and let's remove their guard script. Also, let's remove their nav mesh agent. We only need them as positions in world space here. So here we have point A and point B. Okay? And one of the other things we might want to do is, and I think that's actually okay. I think it's fine. So here we have point A and point B, and we have our waypoints. So what we can do now is let's organize these by guard. So what I would like to do is set up inside each guard, we're going to have a waypoints game object. So let's create a new empty game object inside of our guard. So if you right click it, you can create empty, and let's call this waypoint. Waypoints. and drag point A and point B inside of your waypoints game object. That way, each guard has its own waypoints. See that? All right, so the next thing we want to do here is we have point A and point B. You want to make sure your security guard has its list. And in the next video, we're going to focus on moving between these waypoints for guard 1. I'll see you then. Before we begin creating the waypoint system and moving our guard, there's one thing that I actually would like to fix. In the previous video, I had you create under each guard an individual waypoints game object. This actually will not work because we're going to be moving the guard. So as we move this security guard, that means that the waypoints will also be moving. So instead, what we need to do is we're actually going to create a generic waypoint system outside of this. That's going to be hosted inside just the hierarchy. So select that waypoints object and drag it out of your security guard. Make it so that it's basically its own empty game object here inside the hierarchy, and we have point A and point B here. This is where we're going to be hosting all of our waypoints. And so that we know which guard is going to be going to this, we'll go ahead and name them accordingly. So point A and B is for guard 1, point C is for guard 2, and point like D, E, and F is for guard 3. So I just wanted to take a quick video to let you know that we need to make sure that our waypoints is not childed inside the security guard, as our security guard is going to be moving. I'll see you guys in the next video. In this video, we're going to basically create the ability to move to the waypoints. So here we go with point A and point B. And I noticed something about our waypoints here. Let's make sure that our waypoints don't have any guard attributes. So we want to go ahead and make sure we remove everything inside of them. So inside point A and B, remove these character and guard rigged objects. We don't need them. And inside point B, remove the guard rigged objects. Okay. Now that we have our waypoints there, we have point A and point B, we need to move our security guard between those points. So we're going to create the movement for this. And the movement is done the exact same way that it is for the player, except for the fact that there's no input. So basically what's going to happen here is in an AI system, when you have multiple waypoints, you're going to have a current target. And what's going to happen is that guard is going to move to that current target. Once it's at the current target, it's going to be assigned a new target. So in order to keep track of the targets, first thing first, you need a variable to hold the current target. And that's going to be a transform position. Right? We have a list of transform waypoints, and we want to know at all times who the current target is so that we can assign it a new one if we need to. So let's create a new variable called public transform current target. This is going to be the current waypoint our character is moving to. Before we actually move him using the nav mesh agent, let's actually get who the current target should be. So when the game starts, what we want to do is we want to check if there's any waypoints for us to travel to, and if there are, we want to grab the first waypoint. So let's check out void start, and let's say current target is going to equal, where we'll say waypoints, and then sub-0. This is how you access an element in the list. If we had 5 waypoints and you wanted the first waypoint, you would say waypoint sub-0, very similar to how you access elements in an array. If you wanted the 5th element, you would then type 4. If you wanted the 2nd element, it would be 1, so 0, 1, okay? So here we go, we say current target equals my waypoints 0. Let's save this and let's see what happens. When we run the game here, there should be a few things that go on. And what I'm hoping for is that we're going to get a null reference exception. So if I run the game here, you'll see here that we're going to get a null reference exception. And it's an argument out of range exception. And the reason for this is because if you look at our guard, our first one, it's clearly not null. Like we have a current target, which is point A. As you can see that, current target is point A. But if we look on the other security guards, the current target is none. And the reason for that is because we tried to assign it a transform of an element that doesn't exist. And that's why null checking is so important. So what we need to do is we need to actually hop back into our code here. And before we assign it this first position, or this sub-0, the first element, we need to make sure it's not null. So to do that, we're going to create an if statement, and we're going to check to see if waypoint 0, the transform there, is not equal to null, meaning that there is a transform object, meaning that we have a waypoint, then we will say current target equals the first waypoint. So let's go ahead and save this. Let's rerun this. And you'll notice now that our security guard is going to have the first security guard, we'll have it populated, but the others will remain null because there's no action required. Now it looks like I actually still got another error here, so let's check out what went wrong. So if we open this up, it's saying argument is out of range. So another thing we can do here is if I'm checking for if waypoint 0 is not equal null. So if this transform here is not null, let me see here, argument is out of range. I believe what's happening here, oh, okay, here, so check this out. I'm checking the first element of waypoints, but our second security guard is at 0. In order for this to work, this would have to be 1. So how can I avoid that? Watch what happens now that that is 1. If I set this security guard to 1, and I run this, you'll see here that now the errors are fixed. And the reason for this is because there was no first element here. And as you can see, the game runs fine. We have no current target for this guard, no current target for this guard, but our first guard has a current target of point A. So that's where it's going to be going next. Now, how do we fix that issue with if I want this guard to be idle? He's not going to have any waypoints, so I want him to stay 0. Well, before you null check, what we want to do is we want to make sure that there's actually waypoints. So to do this, what we can do is we can actually come into our if statement here and we can say if waypoints.count, which gets the amount of waypoints in our list, if that number is greater than 0, then we have waypoints. So at that point, what we can do is if waypoints.count is greater than 0, if it is, let's check to make sure that the first point isn't null. So immediately after this, we'll come in here and we'll check to see if it's null. So if waypoints sub-0 is not null, then we're going to go ahead and assign current target. So we'll take current target, and let's place it in here. All right, so let's recap. We have a variable to hold the current target so that we know who our destination is. Because if we have 7 targets or if we have multiple destinations, we need to know who we're moving to. We have a check to see if we have any waypoints for our guard to go to. If we have waypoints, we want to make sure that they're not null so that we're not sending our character to a non-existent place, causing an error in our game. Here you can see current target equals waypoint 0. So now that it has a current target, what you need to do is figure out how do we actually move to that current target. Well, looking at our player script, how did we move here? We said we got a handle to the navmesh agent and we moved it using agent.setDestination. So what we want to do is we want to move our player to the current target. So go ahead and get that working and I'll see you in the challenge review. In this challenge review, we're going to move to point A using the nav agent attached to our guard. To do this, what I can do is in void start here is that's where I'm going to, once I get a handle, I'm going to start the set destination. So in order to have this work, if I look at my security guard here, on this object I have a navmesh agent and a guard AI script. So I just need to do get component to get my navmesh agent. Before I can actually grab that component, if I open up my script here, I need to include the namespace using unityengine.ai. This is going to allow us to access the artificial intelligence library to access the navmesh agent component. From here, I can create a private handle onto the navmesh agent itself, and we'll call it _agent. From here, in void start, I can go ahead and say agent equals get component and we'll go for the nav mesh agent. Once I have a handle to that component, and once we've verified that we do have waypoints and that our first waypoint isn't null, we can go ahead and assign our current destination point, or we can set our destination to our current target. To do that, I can access _agent.setDestination, and we're going to set it to our current target.position. Let's save this, head back into Unity, and we should see that our guard is going to make its way to point A. Let's go ahead and let Unity compile. We'll run this, and the guard is making its way to point A, as you can see here. Now, one of the things that I want to ensure, the guard took the fastest route to get there. The fastest route that it calculated happened to be going this way, going through the guard. So I want to actually ensure that he is going to follow the route that I want him to follow. So that may mean that we need to create another point in between here and go from point A to point B, followed by point C. So in the next video, we will go ahead and together create the system to go from point A to point B, then to point C. I'll see you then. Together, we're going to create and fix the waypoints. So currently, he's moving to point A by going around the cabinet case. That's not the route that we want him to take. Instead, we want him to go from point A to B to C so that he stays within his path. So the first thing I want to do is I want to swap these positions. Let's have his start position be point A. All right, so what I'm going to do here is I'm going to duplicate point B. Let's call this point C. And the first point is going to be over here in the corner. I'm just going to take it and drag it over here, right, where his starting position is. And point B, I'm going to move over to here, in the middle here. And then point C will be at the corner back here. All right, so now we have 3 points. Now our security guard needs to know about that third point. So let's go ahead and add a new waypoint by increasing the size to 3. Here he has point A, point B, and go ahead and drag point C. If you save your scene, and if you run the game, the current target should be point A and he should move to it, which is actually his starting position. And as you can see here, he's moved to his starting position. So what we'd like to do now is move him to point B and then to point C. So how can we set the next target? If he is currently at that waypoint, if he's currently at the current waypoint, he needs to update to his next waypoint. So we need to create logic in here that's going to check if he's at his destination. Very similar to how we actually stop our player from walking and going back to idle, we're going to do the same process to go from our current target, and once we're at our current target, we need to go to the next target. So what is the next target? The next target is the current target plus 1. So if the current target is waypoints 0, that means that the next target is waypoints 1, and if your current target is waypoints 1, and that would mean that the next target is waypoints 2. So how do we go about doing this? Very similar to the same approach we took with the player. Let's go ahead and get the distance between the waypoints. So what we want to do in update here is when do we want to tell it to go to the next point? So currently it's trying to go to the current target, and the current target is point A. So how do we know if you're close to point A, and when should we tell it to go to the next target? We're going to tell it to go to the next target in update here. We're going to check the distance between the current target and the guard's position. So here we're going to say distance, and we're going to grab the distance using vector3.distance. And we need to grab the distance between our player, which is transform.position, and our target, which is our current target.position. And the logic here is going to be, if our distance is less than 1, we've made it to our destination. If distance is less than 1, 0.0f, so if it's less than 1 away from our current target, let's update our current target. So let's go ahead and say current target needs to equal the next index. So what is that going to be? The current target is then going to equal, we'll say waypoints, and we'll pass in sub 1. Now this method here is specific for this guard, and we want to create a modular approach here. So this isn't going to work in our final production, but let's go ahead and test this out. What we should have here once Unity starts is it will go to waypoint A, and then it will update and go to waypoint B. And if we select our security guard, you can see here that the current point is A, and I'm actually getting an unassigned reference variable here. And the reason for that is because current target, this script is attached to all objects. It's attached to every guard, and not every guard has a waypoint 1. So before we can actually do this, we need to check if the current target or the current waypoint is null. Okay, so here we're going to say if waypoints, so if waypoints 1 is not equal to null, then we can assign current target to it. Let's save this. And one thing also that you're going to notice is we actually might not get any movement. And the reason for that is because we never called setDestination. SetDestination was only called an update. Now it says here the variable current target of guard AI has not been assigned. So and if we select this, which objects? It's talking about the second guard here. Okay, so it is complaining about the second guard. So it looks like something is still null. Here we're checking for float distance equals vector3.distance. Oh, current target here. So this distance variable is what's screwing it up. So how can we fix this? The way we can fix this is simply by checking if our current target is null. So check this out. We can actually, in update, we can create a method that's going to check if our current target is not equal to null. And if it's not null, that means that it has a current target. And if it has a current target, then we can go ahead and calculate the distance between the player and the target. If the distance is less than 1, we can check to see if it has a second target, and if it does, we're going to assign it to the second target. So let's go ahead and save this. Let's run Unity. And you'll see here that we have no more errors. It's going to go to point A, which he did. The guard moved to point A, but he's not moving to point B. But if we look on the first security guard, his current target is point B. So what's happening here? Well, what's happening is that we never actually call our setDestination again. So what we need to do is open up some curly braces here. Let's place this in there. And what we want to do here is you want to say _agent. And you want to call the setDestination again. So you're going to say _agent.setDestination, and it's going to be current target. So now if we save this and head back into Unity, and it's current target.position. Save that, head back into Unity, let it compile. Okay, let's go ahead and run Unity. And now it should go to point A all the way to point B. So it's going to go there, and now it's moving to point B. Now what happens once it gets to point B? How can we make it go to point C? So very similar to what we currently have, what we can do is we can go ahead, and here, if distance is less than 1, if point 1 is not equal to null, then we can have another else here. We can have an else if, right? So here, else if waypoints, and we'll go ahead and say 2 is not equal to null, meaning that it has a second waypoint, we can say current target equals waypoints. We'll pass in a 2, and then here, once again, we need to do agent setDestination. Copy that line of code and paste it here. So what's happened here? You notice that we're hard coding this, right? We're constantly writing code. What if I had 50 waypoints? What if one of my guards had 50 waypoints? Am I going to write 50 if-else statements, null checking every single one of those if statements? No way, right? So what are we going to do? We need to optimize this so that, one, it's not hard-coded to any one guard, but it's optimized in a modular approach. So in the next video, guys, I'm going to show you exactly how we can do that. First thing first, I want to make sure that we go from point A to B to C. And as you'll see here, the game's going to run. Our guard's going to go to point A, he's going to point B, and now he's going to point C. And actually, he did not go to point C, and his current target never updated. So let's check out what happened. Here, if distance is less than 1, oh, here we go. So if waypoints 1 not equal null, waypoint 1 is not null. So it's actually being told to go to itself. It's never actually getting to this else statement. So how can we make it get to point? How can we make it get to point C? Well, it's really simple. What we need to do here is we're going to add this, and what we need to do, if waypoint 1 not equal null and current target does not equal waypoints 1. If current target equals that waypoint, then we're already there and we want to move to the next one. So by saving this, that should fix that. And you can already see how messy and just how terrible this is, because now this script is dedicated to one guard and we want to take a modular approach. So finally, let's test this out one more time. Let's see if it's working. All right, go to point A, we'll go to point B, and now we're going to point C. So now we have a system that's super messy but works. So in the next video, we're going to optimize this to become a modular approach. And you can see here that we have some bugs where our guard is now transitioning back and forth between C and B because he doesn't know what to do. All right, guys, I'll see you in the next video. So let's look at a more modular way to approach this problem. Currently, we have a bunch of clutter and start, a bunch of clutter and update, and we can only control which waypoint we move to based on this digit. So if I had 50 waypoints, eventually I would have to say waypoints like 49, right? So obviously it's just a nasty way to do it. So what I want to do is I want to actually erase everything, and I want to restart this from scratch, and let's write out some pseudocode about what the problem is that we're trying to solve. So here we are, we have our agent. Let's delete even this current target. We have a list of waypoints, right? And we have our navmesh agent. Ideally, this is really all we need to actually solve this. Now, one thing I will say is I want to avoid having to type in, if I have 50 waypoints, I do not want to have to type in if-else statements and type in sub 1, sub 2, sub 3, sub 0, and all that fun stuff. So what we're going to do is we're going to have an indexer that's going to specify the current target. So what we can do here is I'm going to create a variable called private int, and let's call this current target. And it's going to be default 0. Okay, by default it's going to be 0. And what we can do now is if I wanted to set the destination to be waypoint sub 0, I could now just say underscore agent dot set destination, and I could say waypoints, and instead of saying sub 0, I can actually say current target. Now with this solution, what we can do here is current target equals 0, so we're moving to the first waypoint. Once we get to the second waypoint, current target gets incremented, and now it equals 1, now it equals 2. We increment current target, eliminating the need for me to have to hard code in any values. All right, so let's delete this, and let's look at what we need to actually plan for. The first thing we want to do before we tell it to move anywhere is we need to make sure that 1, we have waypoints, and then 2, make sure that the waypoints that we have aren't null, okay? So for example, pseudocode would be here if waypoints exist. All right, so that's like the count. So you want to check if the waypoints.count is like greater than 0. And then you also want to check, and we'll say waypoints and waypoints, and we'll use our new index of current target. Remember, it's sub-0 to start. So and waypoints, whatever waypoint we're currently on or we're going to is not null, so not equal null, then what do we want to do? From here, we can say set destination to current target. All right. So what I want you guys to do is I want you to just get this functionality going, and I'll see you in the challenge review. In this challenge review, we're going to go ahead and solve the modular approach part 1. So all we have to do here is we can literally fill in our pseudocode. We're going to have an if statement. We're going to check to see if our waypoints.count is greater than 0, because we want to know if we have any waypoints at all. And I want to know if the current waypoint I'm going to is even null, if it even exists. So I'm going to say waypoints current target not equal null. If the current target is not equal null, that means it exists and we're going to a valid point. From here, I'm just going to say underscore navmesh, or I'm sorry, underscore agent dot set destination, and we're going to move to our current target. So that's going to be waypoints, and we're going to say current target. And don't forget dot position. Save this. Let's test it out. Let's see how it goes. On our security guard, we have 3 waypoints. On this security guard, we have nothing. And on the third security guard, we have 3 waypoints, but they're all null. So we should be checking for every condition, and we should be okay here. Let's go ahead and run our game. And we should move to point A. Now, we moved to point A, and there's no errors, so everything is awesome. Now, I would like to go ahead and see this current target value. So I'm going to add a serialized field to this target value. This will allow us to see it in the inspector. Now, what I'm hoping to see here is that the current target is set to 0 and we move to 0. And that's exactly what I am going to see. Now, in the next challenge, what we want to do is, how do we increment it? How do we go to point B and then C, and then later, how do we reverse it and make it ping pong between A, B, C, C, B, A? I'll see you guys in the next video. In this challenge, we're going to continue on with our modular approach. So let's look and see what we have here. Currently, we have our security guard and our current target is set to 0. When the game starts, he moves to target A. But what we need him to do now is once he's at target A, we need to increment this to target B, which would be 1. So what happens if I change this in the inspector to 1? You'll see here that he moves. And once he's at 1, what's he do? Nothing. He needs to continue moving through. So if I change it to 2, he's going to move to 2. So what we need to do through code is we need to check the distance between the player and the destination, or the guard and the destination, and we need to increment current target. So let's check out the pseudocode for what we need to do, and then I'll let you guys solve it. Head on over to your code, and what we want to do here is we're calling set destination waypoints current target, and then what we want to do afterwards is we want to check the distance. So check distance between guard and destination. And then what we want to do next is if the distance is less than, say, 1, so if distance is less than 1 unit, then what do we want to do? Let's increment current target so that it moves on to the next. Increment current target. So that's going to be your challenge. And what I want you to do, I want you to know that watch what happens as we increment this. If I play this and I increment it too far, what happens if we get to 2 and then set current target to 3? What's going to happen? Let's run our game and find out. You'll see here that I'm at 0. If I put a 1 in here, we're going to go to 1. Once we get to 1, if I put a 2 in here, we're going to go to 2. Now what happens when you get to 2? Our code is going to increment it again. What happens when a 3 gets in here? A 3 is going to break our game. We're going to worry about this after the challenge review. We're going to have a separate video on how to fix this issue. I'll see you in the challenge review. In this challenge review, we're going to look at how to increment our current target through code. So let's open up our script here. And the first thing we want to do is we want to check the distance between the guard and the destination. So as we're moving to our next position, we're going to say if our distance, so we need to actually calculate distance. So distance equals vector3 dot distance between our transform dot position and our current destination, which is waypoints, current target, and then we can say dot position. So this is going to return a value that will have the distance between those two. The next thing we want to do here is check for if distance is less than 1 unit from the destination. So if our guard is 1 unit from actually reaching the target, let's go ahead and increment it. So if the distance is less than 1 unit, we'll say current target plus plus, and that's going to increment it by 1. And it looks like that's all we had to do. If we save this, it should now automate from point A to B to C. And then at C, it should break because it's getting an argument out of range exception. So we will actually look at how to fix that in the next video. So here we go, point B, current target is 2, and point C. And there we go, it breaks. So in the next video, what we're going to look at is how to reverse this. I'll see you then. In this video, we're going to look at how to create a reverse effect. So currently what we need to do is we need to check if current target equals the waypoints, then that signifies that we've made it to the end and we need to reverse. It doesn't matter if I have 50 waypoints, doesn't matter if I have 5,000 waypoints. If current target equals the size of the waypoint, which is the count of the waypoints, then it's time to reverse. So how do we know when it's time to reverse? How do we do that through code? Well, if we look here, here's everything that's happening right now. And what's happening here is we say if distance is less than 1, we current target plus plus. We don't even care. We just increment current target plus plus. But what happens if we're at the end? So right here is where we actually need to check this. We need to check if the waypoints or if the current target after you increment it, if current target equals waypoints.count, that means that we are at the end because numbers start at 0. So if waypoints.count is 3 and your current target is 3, that means that you've made it to the end. You're now past your waypoints, so you need to start reversing. So here we need to say, if we're checking here to say if current target equals waypoints, we need to say reverse. Okay? So what we can do here is we can have some sort of bool system in place where we can maybe we can say reverse equals true. And another thing you're going to want to do is when you do that, after you set that bool to true, we need to say current target. You need to say current target minus minus because it's still 3. So you want to subtract it. So and then here, as long as reverse is true, you no longer want to actually increment plus plus. You only want to increment current target when reverse is false. All right, so you're going to need to create a system that is going to know when you should reverse and when you shouldn't. And then you're going to encounter a similar issue when you're reversing and you go to 0. So we'll go ahead and face that one together as well. I'll see you guys in the challenge review. In this challenge review, we're going to look at how to create the reverse effect. So looking at our code here, the whole problem is that no matter how many points we have, we're calling current target plus plus indefinitely. The problem here is that we don't want to call this, and we only want to call this when we're not reversing. So the question is, how do we know when we're not reversing? That logic doesn't exist, so you have to create it. That means that we have to actually create a bool that's going to create that logic for us. So private bool reverse. All right, so private bool reverse, and by default, it's going to be set to false. So private bool reverse, it's false. We're running through our points, point A, point B, point C. We finally increment the current target, and now we need to fill in our pseudocode. So after we implement our current target, we need to always check, after incrementing this, every time we need to check if we are at the end. Even if we know we're not at the end, the program every time has to check if you're at the end. So we're going to say if. We're going to check to see if our current target is equal to our waypoint count. So you're going to say waypoints.count. If it's equal, you've made it to the end. So if it's equal, you've made it to the end. Reverse is now true. But that's not all. We're still on 3. So we need to say current target minus minus. We need to subtract a target. Now, the next time this runs, what's going to happen? Well, the next time that this runs, you'll see here that current target plus plus, even though reverse is true, is getting called. So how do we prevent this from getting called? Well, we need to actually wrap it in an if statement. So here, if distance is less than 1, if, and we're going to check if reverse mode. So if reverse equals true, then what do we want to do? If reverse equals true and where distance is less than 1, we're going to say current target minus minus. Else, if reverse is false, we're going to say current target plus plus. Just like that. And then inside there, after you increment current target, we're going to put all of this good stuff in there. Okay, and that is our code. So here, we set our destination, we get the distance if it's less than 1. If you're reversing, we're going to go backwards. We're going to by decrementing. Else, we're going to go forward by incrementing, but we're going to always check if we're at the very end. If we're at the end, we're going to reverse, and we're going to remove 1. Let's save this, and let's test it out. Go ahead and let Unity compile. You'll see here that our security guard is moving to current target 1. Current target is 2. And once it gets to current target 3, it should begin reversing. And you can see here, current target is now 1. And current target is now 0. So we successfully reversed. But what's going to happen when we get to current target 0? It continued decrementing, and now it continued decrementing, and it crashed. Same issue we just had. So to fix that, it's really simple. So as you can see here, we have our current target plus plus. All we need to do now is current target minus minus. And every time you decrement this, you just need to check and see if current target is at the beginning. So here, if current target equals 0, then what do you need to do? How do we just tell it to stop? All we have to do is say reverse equals false, and then you need to set current target. You need to set current target equal to 0. That's the start position. So here, current target minus minus, it's -1. If the current target equals 0, that means that there's no more. Okay, there's no more. Reverse is now false, and current target equals 0. Let's save this and test it out. On the next time it runs, it will then begin incrementing again. Head back into Unity, and let's check it out. We should have a fully functioning ping pong effect between ABC, CBA. And in the coming videos, we are going to add some idle states to our points so that they will take a quick breather, maybe anywhere between like a 2 to 5 second wait in between their points. All right, and there we go. Let's say it's going to go to the start. And there we go. Good deal. I'll see you guys in the next section. Currently, we have our waypoint working to where our guard is continuously moving between point A, B, C, and then he's successfully reversing to CBA and back again. Now, what if we wanted to have a small delay in between each point? Or more specifically, for our purposes, we actually want to pause at the first point and the last point. How would we do this? Well, let's go ahead and look at our code here and see what's actually controlling the logic for the infinite movement. For starters, everything's running an update, so we're calling this every frame. We are setting the destination continuously, and then here, what's actually updating the next target? It's this. When distance is less than 1, we're checking if we're in reverse. If we're not, then what we're going to do is we're going to run this code, but if we are reversing, we're going to run this code. And what's important here? What controls which target we go to? It's this current target plus plus and the current target minus minus, because continuously we're telling the agent to go to the current target position. So what we want to do is we want to basically halt execution in here to allow our character to stop moving. And ideally we want to isolate the ability to increment current target plus plus until we're ready to increment it. The easiest way to do this is we can say if distance is less than 0, we need a way to check if we've reached our target. If we've reached our destination, let's go ahead and just freeze. We want to freeze until further instructions. So how do we know how to just create that? Where does that logic exist? Well, that's just it. It doesn't exist. You need to create the ability for that logic to exist by using a bool. So we could have here a bool that's called target reached. And this is going to be responsible for halting our update method. So here we have private bool target reached. By default, it's going to be false. And when we've reached our target, that means that our distance is less than 1. At this point, if this if statement is being called when distance is less than 1, we have reached our target. So what I want to check here, so I want to do here is say target reached equals true. And in order to freeze execution, we want to check if distance is less than 1 and our target reached is equal to false. So if we haven't reached our target yet and distance is less than 1, then target reached equals true. And what's going to happen here is this code will no longer run because target reached is now true and this is now a false condition. All right, target reached is no longer false, it's now true. So we're not going to be able to execute in here. So what's going to happen here is we're going to have, let's add a debug.log in here. For debug.log, let's see here, we're going to say target reached. Okay, target reached, and we can go ahead and actually include the value of underscore target reached appended onto it. If we save this, let Unity compile, and let's run it again. What should happen is we should move to our first point, and then we're just going to freeze. You'll see here, target reached equals true. And we stopped. And there you go. We are frozen. In order for us to actually pick up again, there's a few things that we need to do. For starters, we need to say target reached is false. We need to basically set target reached equal to false in order for this program to continue on so that it executes again and moves to the proper areas. Now, in order to do this, there are ways that you can halt execution, right? So right now, target reached equals true. When do we want to set it back to false? We want to set it back to false after X amount of seconds. So what you can do is you can create a coroutine down here. You can create like a coroutine down here called IEnumerator, let's say, wait before moving. And inside that coroutine, you can create logic that's going to maybe randomize the halt time. So maybe they're going to idle for 2 to 5 seconds, and then you'll go ahead and set target reached equals to false. Okay, so go ahead and give this challenge a shot. You will run into problems where maybe setting target reached to false isn't the only solution here. You need to maybe add additional logic, but I really want you to give it a shot and try to create the idle for the guards. I'll see you guys in the challenge review. In this challenge review, we're going to look at how to solve the idle animation, or not the idle animation, but the idle positioning for our guards. So the first thing that we want to do is let's go ahead and try and just use a coroutine to reactivate our target reached here. So when target reached equals true, here we have if distance is less than 1 and target reached is false, we're saying target reached equals true, and that's halting the program. At that point, let's go ahead and call a start coroutine, and let's call our wait for wait before moving coroutine. Okay, and inside this coroutine, what do we need to do? We need to just re-enable target reached after X amount of seconds. So we're going to say yield return new wait for seconds. And let's say we're going to wait 2.0f. And after 2 seconds, we're going to say target reached equals false. And that should allow the program to continue moving again. So let's let Unity compile and test it out. Let's run Unity. And we can see here that we're going to go to our first position. Our target reached is true. Now, target reached is getting called, and you can see here our debug.log at every point it's getting called, but he's not halting for 2 seconds. Look what happens when he gets there. He just instantly moves. So he's not really halting. So let's figure out why. We're telling our coroutine here to wait 2 seconds. Let's see how often that coroutine is getting called. I'm going to go ahead and say debug.log. This is our wait before moving. And let's see how frequently that coroutine is getting called. And this might help us debug what our issue is. So let's run the game. And here we go. So target reached equals true. And you can see here our coroutine did get called, but it got called again at the next point. And it looks like it's getting called, but what's happening here? So what's happening here is our wait before moving coroutine and our target reach coroutine are both getting called, but our character is ignoring the instructions of staying still. So why would that be? Let's look at the execution of our code and figure out where we've gone wrong. Now, let's go through and see what happens every frame. We check to see if you have any waypoints in your list. If you do, we then check to see if the current waypoint is null. From there, we set the current destination to the current waypoint. We calculate the distance between the player or the guard and the waypoint, the current target. Then we check if distance is less than 1 and our target reached is false. If the distance is less than 1, target reached equals true. Now what's happening here is, I think what's happening is it's happening so quickly that target reached is true for 1 frame. We start the coroutine, but then you'll see here that instantly after starting the coroutine, we go to this. And within the same frame, okay, and this is actually happening within the same frame. So here we've set the target reached equals to true, okay? But in the same frame, we then go through this logic and this logic, and we're already updating the next position. So we're already telling it to go to the next position. And that means that by the next frame, we're already set to the next position. And guess what? This isn't even getting called anymore because distance is now greater than 1. So what we need to do is we actually need to add this logic and this logic to our coroutine because we want to prevent current target and current target minus minus and plus plus from being called. So what we can do here is we can actually remove the coroutine from here. We're going to say target reached equals true here. We're going to check if reversed equals true. Then we want to basically call the coroutine here, and we also want to check, and we also want to call the coroutine here. And we might not even need the logic here. What we can actually do is move the logic to the coroutine. So we can say something like, and let's make sure this works before we clean it up. But here we can actually say start coroutine. We're going to say wait before moving. And then down here, we're going to say start coroutine. And we will also wait before moving. So we're starting both coroutines, whether you're reversing or not reversing. And from there, we need to take this execution logic and add it into the coroutine because we want to only increment it after 2 seconds. We want to say, hey, go to the next target after 2 seconds. So here we call the coroutine and we wait. And here what we want to do is we just simply want to check if reverse is true. So if reverse equals true, then what do we want to do? We want to go ahead and say current target minus minus because we're reversing. Else if reverse equals false, what do we want to do? We want to say current target plus plus because we're going in the proper direction. Now that we have that logic here, let's remove it from here and let's remove it from here. Go ahead and save our script. And what's going to happen now is it should work, but we need to add this logic back. We need to now check for the logic of current target and so forth. Possibly. Let's check it out. So let the code compile. Go ahead and run Unity. And we'll see here that our security guard is going to go to 0.1. He's waiting 2 seconds, goes to 0.2. Let's see. There you go. We now have our idle. So the next thing I want to do here is I want to clean it up, the current execution we're doing. So in here, we have if reverse equals true, if else if, regardless, we're calling this multiple times. I think we can eliminate this entire if else statement. And we can just call our start coroutine right here. So target reached equals true, start coroutine, wait before moving. Let's save that. And I no longer need this if statement. I want to keep this logic though, because I feel like we still need this, right? We don't know when to reverse and when to not reverse. So we definitely still want to hold on to this. However, we can execute this logic down in the coroutine. So here we can say if reverse equals true, we decrement, right? We remove one. And then after doing so, just like we did up here, let's just take if current target equals 0, reverse equals false, and current target becomes 0. Let's take that and put it in here. Then what we can do is we can do the same thing for this logic. We increment, and the next thing we want to do is after incrementing, you want to check if we're at the end, right? You've made it to the end, reverse is true, and then we decrement. So this is now all going to happen after 2 seconds in the coroutine, allowing us to delete this entire if-else statement. Now our code is a much cleaner and much more readable. And what we have going on here is if our waypoints are greater than 0, we set the destination, we get the distance. If distance is less than 1 and target reached is false, we're setting target reached equals true. And then here we're saying start coroutine, wait before moving. Let's save this. Let's test it out one more time and make sure that we can get a full ping pong motion. So here we are, we're at point A, we wait 2 seconds. We move to point B. We wait 2 seconds. And then we move to point C, and we're going to wait 2 seconds. The next thing I want to do is I want to modify it so that we aren't waiting at the center point. We only want to actually pause at the first point and the last point, which means we're going to have to know when we're at the beginning and when we're at the end so that we can only pause during those times. All right, there we go. We have a full rotation. See you guys in the next challenge. Now that we have our AI guard pausing for 2 seconds in between stops, what I'd like you to do in this challenge is make it so that he only pauses at the starting point when current target is 0 and at the end point when the current target is maxed out at whatever the amount of waypoints we have. So when he makes it to the end, when he makes it to the end or the beginning, that's when he should pause. He shouldn't pause at a midpoint. Also, I want you to randomize when he pauses, or randomize the length of time he pauses for. So right now we are pausing for a guaranteed 2 seconds. I want you to randomize it between 2 and 5 seconds. All right, I'll see you in the challenge review. In this challenge review, I'm going to create the functionality so that it only pauses at the beginning and at the end. I don't want it to stop at the midpoints. So let's look at how we can do this. Currently, if the distance is less than 1 and target reach, regardless, I'm telling it to say start coroutine, wait before moving. I only want to do this. I only want to basically call this wait before moving if we're at the start and end. So how do we know if we're at the start and end? Well, we have that logic actually down here. We're already checking if current target equals 0, then we're at the beginning, and if current target equals waypoints.count, we're at the end. So we can simply just create that same logic right in here. Here we are. We are going to check if we're at the beginning. So if current target equals 0. Okay, so if current target equals 0, we're at the beginning. And what I want to do here is if current target is at the beginning, we want to call the coroutine. And else if here we have current target equals the amount of waypoints we have, which is waypoints.count. That means we're at the end, right? So here at end, then we're going to call the coroutine again. And that should solve that problem. Like Unity compile, and we'll run this. Run Unity. And as you can see here, our guard is waiting for 2 seconds. Wait before moving was called. He should skip the second position. And let's see. So he did not skip the second position. So the question here is why not? And it looks like he's actually stuck. So we actually have a bit of a bug here. So what happened? Why is he stuck there? If we look at our code here, we have target reached equals true. If current target is 0, we call the coroutine. Else if current target equals waypoint, we call the coroutine. The problem here is that we have other logic that the program relies on happening inside the coroutine. So what might actually be better is we will go ahead and actually maybe do all of the logic in the coroutine and just determine whether or not we wait only a frame or we wait an actual 2 to 6 seconds. So let's go ahead and actually undo what we did here. So we're just going to delete this. And in here, we're going to say start coroutine, and we're going to call the wait before moving. Let's save this. And one of the things that we can do is once we're in the coroutine here, we're going to say wait before moving was called. Before we even do this, let's check in here if we're at the start position or not, this or the end position. So here, if current target equals 0, we're at the start, we're going to go ahead and say, we're going to say yield return new wait for seconds. And how long do we want to wait for? Let's say we want to wait between 2 and 6 seconds. Wait for seconds. And here we'll go ahead and say, and just for testing purposes, we'll say 2 seconds before we change it. So here, if current target equals 0, we're going to wait 2 seconds. Else if current target equals waypoints.count, meaning we're at the end, we'll say yield return new wait for seconds, and this will be 2 seconds. Okay, here we can remove this one. And what's going to happen now is if current target equals 0, we're going to wait 2 seconds. Else if current target is the end, we're going to wait 2 seconds. Otherwise, we're just going to continue right on through. If we save this, this should be okay. So let's run it. Let Unity compile. All right, here we go. So we go to the first stop. We're there for 2 seconds. We should now skip over the second stop. And there we go. We should now wait for 2 seconds. Now we didn't wait for 2 seconds at the very end. So let's see what happened there. And you can see here we kind of slow down at the second waypoint. So I'm not totally happy with that behavior. So let's relook at our code and see what we can fix. Currently what's happening here is, I think the idea situation here is we don't want to get into this coroutine possibly. If we look here, we say target reached. We start the coroutine wait before moving. And what we want to do here is wait before moving. We may need to split the logic out into 2 parts. Let's see here. If current target is 0, that means we're at the beginning. We're going to wait 2 seconds. If current target equals waypoints.count, we're also going to wait 2 seconds. And then instantly we should just, this will act as a normal function here. If reverse equals true, and possibly if we say else yield return null, that's going to say regardless, just wait a frame. So let the program breathe, basically. And let's see here. If reverse is true, we're going to increment or decrement current target. All right, let's save this. I just want to see how this is going to function. I also want to add a debug.log here. Debug.log at the beginning. And then I also want to add a debug.log at the end. Debug.log at the end. Let's save this, head back into Unity. Let's compile and run. All right, so we're at the beginning. We waited 2 seconds. Here we are. Okay, that looked a lot better. And let's see what happens here. It should recognize that we're at the end. Okay, so it did not recognize that we're at the end. So why not? If we notice current target was 2, however, current target is never going to equal 3 at this point. It's never going to equal this. So what we need to do is say else if current target equals waypoints.count minus 1. And that's going to give us, that will give us our endpoint. So if we save this, head back into Unity, let it compile and run it again. You'll see here that we're going to wait at the beginning for 2 seconds. We're going to move to the middle. We're at that waypoint. We're going to keep walking. And here we are at our third point, and we're going to wait 2 seconds. Now, after that 2 seconds, we should go back and ping pong. And there we go. Alrighty. So it looks like everything is happening really well. So one of the things I noticed is there's a little bit of a slowdown as soon as we get here. And I'm wondering if we can modify that property here by changing our stopping distance. If we change the stopping distance to say 1, let's see what happens if he continuously moves through it. Let's change it to 2. Wait 2 seconds. And it looks like he's just going to slow down there. I'm not terribly upset with that behavior, but if we did want to perfect it, there's something we might be able to do in the code. Let's open up our script again. Head down to our coroutine here. And one of the things that might be happening is this. So let's see if we no longer need this. And let's see if it will run as a traditional function now. So here, if reverse is true, we just want to say current target plus plus and move on. Let's run this. Here we are at the beginning. We're moving. And there we go. It looks like it's still paused for a split second. So let me see what we can do to fix that. One of the things that we actually might be able to do is right here. If distance is less than 1 and target reached equals false, and you're not at the beginning or end, or maybe it is, maybe you're at the beginning or end, right? So if distance is less than 1 and target reached is false, and what we can add in here is and let's put this in parentheses here. We can say and we'll say current target equals 0 or current target equals waypoints dot count minus 1, because remember numbers start at 0, and we can go ahead and save this. So here, if distance is less than 1 and target reached equals false and we are not at the starting point or end point, then what do we want to do? We should continue on to the next waypoint. So here we may need to actually do a little bit more logic here, because I think what's going to happen now is it's not going to know where to go. Like, it's not going to increment our destination at all. Right now, it's just going to skip this coroutine. So that might not be exactly what we want now that I think about it. So this logic here is for if we're at the start or the end, we want to wait before moving. That's correct. But what if we're not at the start? We want to say else. If we're reversing, if reversing equals true, then what do we need to do? We need to say current target minus minus, else we're not reversing, and so we're going to say current target plus plus. And this here should allow it to skip over the wait before moving part and just continue on in our path. Let's save this, head into Unity, let it compile, and let's run it again. Here we are waiting for 2 seconds here. And it looks like we have an argument out of range exception. So let's take a look at what happened. it looks like what happened here, if distance is less than 0, we are just... Oh, okay, so here we're infinitely... Okay, so we don't want to do that. We are infinitely checking, or we're infinitely incrementing and decrementing this value. We actually don't want to do that. Instead, this logic actually needs to happen inside the if statement because we only want to do this when distance is less than 1. So let's go ahead and remove it from here. And inside here, we're going to take this code and we're going to put this in an if statement. So here we have if distance is less than 1 and target reached equals false. What we're going to do next is we're going to check to see if you're at the beginning or end. So if current target equals 0 or current target equals waypoints.count minus 1, you're either at the beginning or the end. We want to do this. We're going to say target reached. Else, we want to check if we're reversing. So if reversing equals true, then we want to current target minus minus, and then the opposite. Else, we're not reversing, and current target plus plus. This way, we only increment when distance is less than 1. So once we've made it to the next point. Let's save this, test it out. We're moving to our first point for 2 seconds, and let's see if he's going to stop. And there we go. So for some reason, he is stopping. I no longer think it's related to the code. I'm almost positive it might be related to the stopping distance. Let me see if the stopping distance will affect anything. It's not affecting anything at runtime, but let's change it to like here. And let's actually turn off auto braking. Maybe that's what was preventing us from using it. I believe what's happening is it's coming to a halt because it's getting close to the point at this point. So let's run this. And there we go. Now he's smoothly going through. So it looks like it may have actually just been the auto braking that was causing him to actually have that slowdown. But either way, we have the behavior we want. So here you go. And no pause. Good deal. All right. So I'm very happy with this guard's behavior. And just as I was about to end the video, it looks like we have an argument range out of exception. So what would be causing this for this guard? As you can see here, current target became -1. So we want to prevent that from happening. As you can see here, as we are decrementing here, it looks like this else statement still got called. And what we want to do here is after we decrement, we definitely want to make sure that that can't happen. So if current target, we're going to go ahead and say if current target equals 0 after decrementing, or actually if current target, let's see what the value is when it gets here. So current target, basically what we want to do is if reverse equals true and we subtract current target again, we need to just do a similar check here. So if current target equals possibly 0, although it would be -1 at this point, I believe. So maybe if it's less than 0, if it's less than 0, or we can even do equal to 0. If it's less than or equal to 0, set current target to 0. And that will resolve that issue. So let's save this. Let's head back into Unity here. And let's verify that this is okay. We want to make sure that we can get a full ping pong movement from ABC to CBA and back again. All right, so we're at the first checkpoint. Our current target is 1, so we're moving to the second one. Our current target is now 2, which is going to be the end because we're checking for the waypoints.count -1. We're going to wait 2 seconds. We come back. We go ahead and go to point 0. Current target is 0. All right, and it still went to -1. So now the question is, where in our program is it setting it to -1? Where are we decrementing where we shouldn't be? So let's look in our code here for the check. I'm not 100% sure that it's actually happening here, the error. This actually could be occurring in our coroutine. For instance, we have here, if reverse equals true, current minus minus. If current target is 0, reverse is false and current target equals 0. One thing I noticed here is I didn't say reverse equals false. So we need to say reverse equals false so that now we can go back to a forward motion. Once again, save your scripts. Let's head back into Unity. We'll go ahead and run this again. We get to our first point at the beginning, we wait. Our current target is now 1, so that's point B. Our next target is point 2, which is C. We're going to wait 2 seconds here at the end. Going to return. And let's see, our current target is now 0. So what's going to happen once we get to here? And there we go. All better. All right, guys. Hope you enjoyed the challenge review. I will see you guys in the next lecture. Now that we have our desired AI behavior, let's go ahead and focus on creating the animation for this guard. So just like our player, if we select our guard here, he needs to have basically an animator component on him. So what we want to do is create his animator controller. So if we go to our animations folder, we have Darren, and then we also have the guard. If you right click the guard, we can create an animator controller. Call this guard controller. If you double click it, it will bring you to the animator view, and we can drag in the idle and the walking alerted. We're going to use these two animations. The other two animations are for potential future content within this course, where maybe there's a chase feature where the guard is alerted. There's a capture feature where when he grabs Darren. But for this course, we're just going to use walking alerted and idle. So let's look at walking alerted and idle. What we want to do here is create the visual logic for when to move from idle to walking alerted. And very similar to the concept that we did with Darren going from idle to walk, we're going to do the same thing. So let's create a parameter by going to the plus icon here, and let's create a new bool. And we'll call this walk. Okay? From there, when do we go from idle to walking alerted? We do that when walk is true. So here, if walk is true, we're going to go from idle to alerted. And it looks like something in the animation here in this preview is not working at the moment, but we'll see if if the animations work. They should. Okay, it looks like there's actually a model over this for some reason. Weird. I hope you guys aren't experiencing that as well. But one thing we want to do is make sure exit time is off because we don't want to wait for idle to finish. We just want to move right into it. From there, when do we go back to idle? We create a transition to go back to idle when walk is false. And make sure it has exit time is off as well. Save your scene. Idle is the default. If we run this, nothing's going to happen yet because our player or our guard doesn't have the animator component. So let's add the animator component here. So here's our animator, and he's looking for a controller. And that controller is going to be our our guard controller. From there, we should be good to go. Let's save our scene, and let's run Unity. Here we are. So as you can see here in the scene, he's got his idle animation playing. You can see him here. He's kind of, let me see if we can freeze him for a moment and look at him in the scene view here. His idle animation should automatically be playing, and it looks like it is. You can see here, his hand is kind of swaying, it looks like. Let's make sure, yeah. You can see here his hand's kind of swaying. And he has a little bit of movement to his neck to show he's just looking around and kind of just patrolling, right? So what we want to do is we only want to play the idle animation when he's actually stopped. I'll see you guys in the next video. So what I'd like you to do in this challenge is I want you to basically create the animation state for this. So we visually set up our behavior tree. And what we need to do now is, if we look at our guard here, we need to get access to this animator component through the guard AI script. And from there, we want to trigger that bool property that we created, walk. When should it become true and when should it become false? If we look in our code here, after you get a reference to your animator, what we want to do is where in this logic do we want to animate walk, and then where in the logic do we want to say, hey, let's go ahead and be idle. Remember, idling happens within our wait before moving method. So I will see you guys in the challenge review. In this challenge review, we're going to set up our guard animation. So looking at this, the first thing I need to do is I need to create a handle to the animator component. So on the guard AI, we have private animator, and I'm going to call this anim. And in void start, we're going to say underscore anim is going to equal our get component, and then I want the animator component. Now that I have a reference and a handle onto our animator component, we can look at the logic of where should I place this to begin walking. Well, here's what we do know. What is actually causing us to move? It's this line of code right here, set destination, walk, right? So what I'm gonna do is if I'm moving, this here signifies that I'm moving to a position. I wanna assume that I'm always gonna be walking. So we're gonna say anim.setBool walk, and the value is going to be true. We'll save this. From here, where do I want to be idled? Well, if I'm in this wait before moving, if I'm at the current target, or if I'm at the end target, I want to be in idle. So I'm going to go ahead and I'm going to say anim.setBool walk is going to be false, and that will transition us to idle. The same thing goes for right here if we're at the end. If we're at the end, I'm going to say anim.setBool walk is false. Let's save our script, head back into Unity, and test this out. Let the code compile. All right, and here we go. So right now our guard is walking. And let's see if he goes to idle. And he does. So he went to idle for a split second. It looks like he's almost confused on his animation. Let's check that out again. Here he is, he's walking. When he gets to the end, what happens? So it looks like he goes to idle for a split second and then he stops. Now, why is that happening? The reason why that's happening, guys, is because we're telling it to, for one frame, we're saying, hey, go to setBool walk, right? But check this out. What's happening here is immediately on the next frame, we're telling it an update to go to the walk. So to fix this, we don't want to set bool walking here. Instead, what we want to do is if the distance is greater than 1, we want to walk. So if distance is less than 1 and target reached equals false, we're going to do all this fun stuff. Else, we're going to keep walking. So here we have else. And actually, this might conflict with our other code about stopping in the middle. So let's rethink this. Let's relook at this problem. Here we have if distance, so here, if distance is less than 1 and target reached is false, this is checking for if we're at the beginning or the end, right? So here, if we're at the beginning or the end and distance is less than 1, then in here, what we want to do is say, we want to go through and we're going to idle. Else, we're going to keep walking. So actually, it might be okay to do that here. So in the else here at the end of this if statement, so if distance is less than 1 and target reached equals false, we'll have an else statement here. Else, we're going to say anim.setBool walk. So we always want to be walking if our distance is greater than 1. Walk and set it to true. Let's save this, head back into Unity, let it compile. Hit play, and let's check out the result. So here we are, we have our guard. And it looks like he's walking still. He's at the beginning, but he's walking. So now it looks like we're not idling. So let's see why that is. Let's go ahead and zoom in on him. Let's see his behavior over here. And once again, he's doing a 1 frame idle and then continues to walk. So let's relook at our code and see where we went wrong. So here we have our distance. If distance is less than 1 and target reached equals false, we're going to wait before moving, And then this is happening again. So distances, let's see here, target reached equals true. The question now is, if we're not at the beginning or the end, then what are we doing? We're just incrementing to our next target, right? So walking, let's actually try rewriting this logic a bit. Instead of doing it that way, controlling it based on the else here, let's just simply check here the distance. Let's control it just by distance. Let's say let's go ahead and say if distance is less than 1, then we want to go to idle. So if distance is less than 1, we'll go ahead and say underscore agent dot idle, or I'm sorry, dot set bool. I'm sorry guys, not underscore agent, it's underscore anim dot set bool. And what do we want to check here? We're going to say walk. So if distance is less than 1, walk is going to be false. We're going to go to idle. Else, we want to keep walking. Let's try something as simple as this. Walk, and we'll say true. Let's save this. Let's remove where we're doing it currently here. So here and here. Let's save that. If we look at our script here, if distance is less than 1, we're not going to be walking, else we're going to continue walking. Let's save it, head back into Unity, let it compile, and try this out. Alright, so here we are. Looks like our guard is walking. Let's see him move. He went to an idle for a split second. We're going to fix that. He gets to the end point, and there you go. He is now idling. His flashlight is pointing towards the ground, just hanging out, and then he begins moving again. And now you'll see here at the midpoint, he puts his flashlight down for a split second. Let's avoid that. The way we can avoid that is we can check if distance is less than 1, and we want to check if we're not at the beginning or end. So the way we do that is we say if and, we're going to put it in parentheses, we're going to say and current target does not equal 0, and current target does not equal waypoints.count minus 1. So we're not at the end. If we save this and test it out, we should be good. So now we're only going to idle if, let's see here, we should only idle if distance is less than 1 and our current target, and actually I'm sorry, I think this logic is backwards. We want to position this somewhere else. Let me copy this out. So from current target here, let's copy that out. Here we have if distance is less than 1, we want to go to idle. Else if, we're going to say else if. And actually, I'm sorry, we do want to check if it's not. So yes, that was actually correct. So if distance is less than 1 and current target is not equal to 0, all right, that means that we want to keep walking basically. Although this bool here is going to set walk to, it's going to make us go idle. So when do we want to idle? We only want to idle if current target does equal 0 or the last one. So I did have that logic backwards. So here, if distance is less than 1 and current target equals 0, which is the beginning, or current target equals the waypoint, equals waypoint.count minus 1. So if distance is less than 1 and our current target is at the beginning or our current target is at the end, we go to idle. Else, we walk. Let's save it, head back into Unity, let it compile, and we'll run this again. Hit play. And let's see here. He's in idle, just hanging out. He walks. And there we go. No midsection idle. And let's make sure he can ping pong successfully back and forth. Idle. And there we go. All right, let's make sure he's not going to ping pong idle. All right, we're good to go. The next step here is let's go ahead and animate all of the guards. I'll see you guys in the next video. In this video, we're going to set up the other AI guards so that they have their waypoints and their animations attached. So the first thing that we want to do is select our second security guard, and let's determine what his waypoint is. This guard is just going to be idling right here, so we're not actually going to be moving him. Now, we may need to actually give him a waypoint position, though, in order for it to work with our animation system. Because as you can see here, we're calculating the distance between a waypoint. So we want to make sure he at least has a waypoint. So what we'll do is we will create a waypoint. Let's duplicate point C, and we'll call this point D. So here we have point D. And let's move this in front of this guard. So he's going to maybe walk to about here, and then he's just going to idle. That's going to be his spot. From there, we want to create the points for this guard. So let's create point E. So here we have point E. And let's position point E back here. Let's duplicate point E, create point F, and let's move this to our intersection up here. From here, we'll create point F, and we'll duplicate that, and call this point G. And from here, we're going to move our point to the left, and then we'll also create another point, duplicate point G, and call this point H. And we're going to move this point to the right side. So this guard is going to be unique because it's going to have the ability to choose between its points, and we'll get to how we're going to factor that in a moment. So this guard here is going to have a bunch of waypoints. So let's go ahead and set up the waypoints now. So we have all the waypoints set up that we need. Now we need to actually assign them. If we select our first guard, he has his waypoints and he's all set. Now for the security guard 1 or for security guard 2, this guy needs waypoints. So the current size is going to be 1, and we're going to drag in point D into his list. From here, what we want to do is we would like to select our third security guard, and let's drag in the remaining waypoints. So we have, for him, we're going to have E, F, G, and H. So he's going to have 4 waypoints on the third guard. So waypoints, he's going to have 4. And we're going to pass in E, F, G, and H. Now these guards know what their waypoints are. So let's go ahead and run the game, and let's check out the functionality that we have. We're not going to have any animations, but we will have the behavior. So if you try and run this, it's actually going to give you an error because it's trying to access an animator component that doesn't exist. So let's create the animator component. And also, this actually creates a new best practice here where you should be null checking before you actually call on to one of your components. So to make it so that there's no error, one of the things that we can do, and what I always recommend you do, is null check this. We're basically acting on this component before we even verified that the component exists. We're assuming it exists. So where are we actually making use of that? Right here. So simply all we have to do is create an if check. That's checking to see if the anim is not equal to null. So if the anim component is not equal to null, then we will do the animation. And we'll do that as well for anim set bool right here. So if the anim component is not null, meaning it exists, not equal to null, we'll add this code inside here. Okay, if we save this and run it again, we'll no longer get an error, and they should move just as we expect them to. Let Unity compile, hit play. All right, here we go. So only one of our guards has the actual animation working, and that's because he has a null check, and it verifies that the component exists, and these other guards here aren't doing anything. Now, we got into an argument out of range exception here. And what we want to do is we want to check out what happened. So if we select the error, it points to security guard 2 in the inspector. If we select him, what happened is that his waypoint was set to -1. So we need to verify that you have no other waypoints because we want him to stay at that waypoint and do nothing else. The current code that we have is assuming you have multiple waypoints, and when you get to the last one, it needs to reverse or continue going, right? So what we want to do is limit this. We want to create functionality that says if you only have one waypoint, than just staying idle indefinitely. So looking at our code here, where does this logic occur? Here we're checking if distance is less than 1 and you're at the beginning or end. You choose to be in walk or idle state. Then here, if distance is less than 1 and target reached is false, and if current target is 0 or the current target is at the end, then we go into this coroutine where we wait before moving. So here is where the issue is. We basically want to say, don't get into this if statement. So we only want to get into this if statement if we have multiple points. So what we can do here is we're already checking if current target equals 0 or current target equals the end. We also want to add an and statement in here that says and waypoints.count is greater than 1. That's going to mean that you have more than 1 waypoints. Let's save that, head back into our game, let Unity compile, and run this again. So here we are. The guards are moving, and it looks like that didn't quite fix the issue. It looks like security guard 2 has a current target of 1. Current target is 1. Okay, so now he's made it to the end, it looks like. So it's no longer at -1, it's now a 1. And it looks like we have this similar issue here. So he's made it to the end. And it looks like he somehow got in here. His waypoints.count is greater than 1, which it's not. He only has 1. Let's go ahead and debug.log if this is what's causing it. It's not greater than 1. So what's happening here now is he's actually getting into this else statement. So inside this else statement, we also only want to do any of this behavior if the waypoint count is greater than 1. So let's just wrap that into an if statement. So here, if waypoints.count is greater than 1, then we'll go ahead and get in here. Save this. And now that I think about it, another thing that we could have done is we could have just checked here in the beginning if distance is less than 1 and target reached equals false. You can actually just create an if statement here that says if waypoints.count is less than if waypoints.count is less than 2, meaning that you have 0 or 1, then we can assume that you only have 1 position to go to, and we can just simply type the return keyword here, and that would also give us the same effect. So I'm going to comment out this implementation and add it back. Okay. Let's save this and test it out. Head back into Unity, let it compile, and run the game. Okay, so here we are. Our guard is moving. There's no errors anymore. And you'll see here that this guard is moving as well. So now all we need to do is hook up the animation. To do that, we just need to select all of our security guards. So here's the first one. Let's select the second and third. Add component, animator, add the guard controller that we created. Hit enter, save your scene, run your game, and you should be good to go. Now we have all of our guards moving. They all have their animations. They're all going to idle, and we're good to go. And let's make sure that this second guard here, this third guard here, can ping pong back and forth between his points. You'll see he goes here, and then he moves to over here. So I'm actually happy with that behavior, so I don't think we need to modify that. There he is in the idle state. And there we go. All right, so we have our guards. I'll see you guys in the next video. In this video, we're going to look at how to create eyes for our artificial intelligence. How can we make it so that they can see and detect Darren as he walks through here? In video games, there's a few ways you can create eyes. For instance, you can use raycasting to raycast from their eyes and have a line of sight. You'll get a very accurate representation of human eyesight if you do it this way. Another way to do it that's really, really simple is you can actually create a game object that is going to be like a trigger, and it's just in front of them however far you want them to see. For simplicity's sake, this is the route we're going to take. So what we can do here is we can select our security guard, and let's create a 3D object, and let's create a cube. For this cube, I want to raise it up to about chest level, I'd say. And what I want to do here is let's go ahead and bring it in front of him so that it's like attached to his nose almost, or on his chest. And what we can do now is we can actually scale this out in the right direction. Or let's do it in the Z direction perhaps. We want it to go in his forward direction, yeah. So basically what I'm going to do here is I want his line of sight to be the length of this cube. So this is going to be this guard's line of sight. So here we go with the guard's line of sight here. And what we can do now is we can turn off the mesh renderer, and we have this box. The next thing you want to do is you want to make sure that isTrigger is set so that objects can pass through it. And what we're going to do is we're going to create a script in the coming videos that's going to be attached to this cube, and it's going to detect the player. And when it does, we'll trigger our game over cutscene. So on this cube, let's rename this to eyes. Every security guard is going to have a pair of eyes, and this is our eyes for the first one. So let's go ahead and add eyes for our second one. All right, and what we can do, that looks like it's actually a pretty broad range, and ideally it should be, but it also is a dark lit environment. So go ahead and make it a size that you're comfortable with. So I'm going to make mine about here. Okay. Once you're happy with the size, you can go ahead and click on your next guard. You can duplicate this game object and drag it into the next guard. Zero the position out. Rename it so that it's eyes. And go ahead and position it in front of the guard. All right. And last but not least, we'll duplicate it again, put it into the third guard, rename it so that it's eyes. Zero out the position. All right, and let's go ahead and make this in front of him. So now what should happen is, because they are child elements of the guards, as this guard is moving, we should be able to see these boxes rotate with the characters. Let's save our script. Oh, I'm sorry, let's save our scene. Make sure isTrigger is checked on all of the eyes. Okay. Let's save our scene, run the game, and let's check this out. This is a very simple solution to letting our AI see. And as you can see here, if I select these guards, their eyes are rotating with them, and we've created a very simple line of sight. In this challenge, I want you to create the ability to be detected by the eyes and trigger our game over cutscene. So to get you started, let's create a new C# script and call it eyes. Let's select the eyes of our security guards. Let's select them all at once by holding down the control key and selecting the eyes. And what we can do here is we can select them all, and let's drag the eyes script over into the inspector panel. This will add the component to each object. From here, double click the script to open it. With the eyes script open, let's talk about the logic that needs to happen here. We can delete everything inside of here. The eyes is a trigger game object, and what we want to do is we want to create the ability to detect Darren when he's caught in our eye. So create the ability to detect Darren when he's caught in our eye. So how can we do this? So we're going to need a function to detect him, which is our void on trigger enter, right? So you're going to need your void on trigger enter method so that you can detect Darren. Once you have that method, you want to make sure that you check that it's colliding with Darren, because remember, those colliders are going to hit everything. We only care if it touches Darren, who has a tag of player. So check that it's Darren. All right, so tag of player. And if it is, what do you want to do? You want to enable the game over cutscene. And to enable it, all you have to do is literally just turn on the game object, get a reference to that game object, and turn it on. And we should be good to go from there. I'll see you in the challenge review. In this challenge review, we're going to create the eye functionality. So let's simply just fill in our pseudocode. The first thing I need is void on trigger enter, which takes in a collider. That takes in a collider and other. Once we've had our on trigger enter function, we need to then check for the player. So I'm going to say if other.tag is equal to player. And it looks like I've lost my tooltip. So I'm going to close Visual Studios. I'm going to save it. I'm going to redouble click the script and reload the solution. That should bring back the tooltip capabilities. Okay, so let's go ahead and test this out again. Here we go. So now that we have our on trigger enter, we're going to say if other.tag is equal to player. All right, so that's Darren. Then what do we need to do? We want to enable the game over cutscene. So to do this, our eyes are going to have a script on them, or a variable on them called public game object game over cutscene. Let's save this, hop into our code here at line 18, and we're going to say game over cutscene dot set active is true. Add a semicolon. Save this. Let's head back into Unity, and on each of these eyes, there's going to be a slot here to enable a game object. So let's let Unity compile. And what we want to do here is on each of these, we want to add the game over scene object. Now, to find that, we drop down our cutscenes, and we see here that we have a game over cutscene. Drag this object into that slot. Now, each of our eyes has a reference to that object, and it's looking to detect Darren. If we save this and we run our game, when we get detected by the guards, it should then trigger our game over cutscene. So here we are. Let's move. And we'll want to fix our main camera here. It looks like our main camera, the quality dropped on our main camera here. Oh, I'm super zoomed in on my main camera. That's why. Okay, so here we go. Let's see what happens if I get caught by this security guard here. So I'm going to go ahead and step right in front of him. And let's see what happens when he turns around. So nothing happened. He definitely saw me. Now, why wouldn't that be working? The reason why that wouldn't be working is because if you remember from the documentation of on trigger enter, it requires the eyes, at least one object must have a rigid body attached. So let's select the eyes and let's add a rigid body component. Make sure gravity is off so the object doesn't fall. From here, save your scene and let's run it again. All right, so let's run our game. Let's go ahead and move Darren over here. We're going to step in front of our security guard, and he should detect us. And there we go. Game over. And here we go, and we should fade out. Very nice. All right, so we want to bring this to life a bit more by adding in some audio, and when we have our game actually like running, when we have like a background music and everything like that, it's going to bring it more to life. So let's go ahead and run this again. Let's go ahead and get caught by the guard. All right, so here we are. Here's the guard. Let's get in front of him again. And it looks like it's very abrupt when it happens. So let's go ahead and see what happens here. Let's get caught. The security guard will turn around momentarily. All right, there we go. So it just cuts right over to this game over scene. Now I'm wondering, did we forget to add a fade effect to that? Because there should be a fade effect when we get in there. If anything, I may want to make the fade effect a lot longer so that we're not getting any jerky camera movements. So what I want to do here is open up our timeline just to verify. But other than that, the functionality is working really well, and I'm happy with the result. If we open up our cutscene, let's look at our game over cutscene. Let's enable it. Double click the playable director to open timeline. And let's go ahead and just preview this. So we do have a quick fade from black to alpha, but you'll see here that it's very quick, it seems. So one thing I want to do here is let's definitely increase that. So we have our camera fade to alpha, and I want to open up the dope sheet of this, and I'm just going to drag it out. I want this to take way longer to go to alpha. So maybe like a full second to actually go to alpha. If we view the game view now, we should see here that it should be full alpha. And let's see. These are the image properties. And if we look here on our game over cutscene, if we look inside there, we have our canvas here. Let's view this camera fade alpha. Let's see what's happening. I'm going to lock the inspector here for a moment. Going to select my game over cutscene, and let's look at this fade. So already the fade is happening way too quick, so definitely want to slow it down. Now I was hoping that by increasing this out, that would help, but it seems like it's not doing anything. Let's go ahead and test that out. Yeah, I'm honestly not 100% sure what that value is. I'm wondering if that value is actually something else. Let's see here. If we look in the game view, we may need to re-record that fade. So let's see here on the game over cutscene. We have our playboard director here. We have our camera fade. And let's see what's happening here. Image color. And if I open this up, yeah, it should be that this here, although it looks like we have 4 points here. Yeah, fade in to fade black. So it's going to start black and go to alpha. So I'm going to delete this alpha key here. I'm going to re-record it. So looking in our game view here, we're going to, and it looks like it's still working just as normal. So I'm not 100% sure what that frame was actually doing. It looks like this is what's controlling it though. We can modify this. Okay, this is our fade here. So let's control that. So we want to go from black. We basically want to go from black. I'd say right here is when we want to fade. Let's try that. We can control these points on the graph. So here we are. All right, for the most part, I think I'm happy with it. We can modify it later if we need to. So I'm going to go back into the scene. Let's rerun this. I'm going to turn off the game over cutscene game object. Let's run this again, and let's get detected by the guards. Oh, and we're also, because we got into that cutscene, it looks like my main camera got adjusted. So 1 second here. We just have to click and trigger that first camera so we can get our cut back. We're going to fix this issue. When you go into a cutscene, your main camera takes the last position of the virtual cam. So we'll look at how to fix that later in the course. So we got caught, and that looks a lot better. So there was a longer black fade there. All right, and there we go. Don't worry about any of the menu items. We'll get to that when we do the menu item section of the course. I'll see you guys in the next video. In this video, I want to fix it so that after we go to any of our cutscenes, like getting captured by the guards, that when we rerun the game, our camera has a starting position. So to do this, it's really simple. And what we can do here is if we just add to our look at player here, we can just simply say at void start, because it's only going to get called once in the game. We can come into our look at player script and say void start. And inside here, let's set the start position to that camera. So here we're going to have a public transform we'll say start camera. And we're going to say that this script, or this transform, so transform.position, is going to equal start camera dot position. We also want to adjust our rotation. So we're going to say transform.rotation equals start camera dot rotation. Let's save this, head back into Unity, and we should be able to simply drag and drop the first camera on here. So if we go to the camera progression angles, we have camera 1. We want to drag that onto the main camera where we have a variable slot. So if you look on the main camera, drag camera 1 into our look at player script where it's looking for the start camera. If we save this, when we run the game, our camera should be at the start position. And there we go. Last but not least, let's go ahead, save our scene, and create our published changes, or commit our published changes. So here we finished AI system. I'll see you guys in the next section.